Hi, my name is Steinkrauss and I'm with Unified Automation. We are doing software development kits for OPC UA client and server development. Today I want to talk about the polling versus reporting mechanism inside OPC and where we see the difference of that. And typically you use OPC UA with notifying, and you get notifications for events, or you can get notification for data. An event is some unconditional or conditional event that's fired, and an alarm has a conditional state and even additional information, and it can be acknowledged. But also data, as you all know, can be sent by notification. So you ask the server to notify you if the data has a value or state change or even a timestamp change. And that's the normal way how to use OPC UA with a notification mechanism to get the data. But there's also a possibility to read the data. And it's ad hoc read, so if you need the data once, or you can do it cyclic, which we then will call polling, which of course is more stress for the server. So the use case makes a difference here. So you need to consider that typically the client asking the server with a very small token, and then if the server has detected change in the data at the source, then he will notify you with the publish. The publish is a big error here because it contains the data. With read, that is different. With read, you will send a quite large message from the client to the server because you need to give a list of all the nodes you want to read. So it's a quite large message that you need to send containing that list. And then in a return, you will get the data back for all these items you have asked for. So in both directions, it's a big traffic. In the publish, it's already optimized. So that's what you need to consider. And second, of course, if you read on the server, then you may put load on the source. That depends on where you configure your max age. So when reading, you can define the max age. And if the max age is now, then the server needs to grab the data directly from the source. So the read goes through directly onto the source. And of course, this can create extra load if you do this at high frequency. And there's another trick. You can reduce a little bit this read request information. If you register the nodes, then you don't need to send the list of all the string node IDs. You send a list of all registered node IDs. And this makes it easier for the server to identify the nodes which you want to read. And so this message here, the read request, will get smaller, and the server can process it faster because it already contains the information, the registered information, and then he can send the data back more quickly. We will look to that in a detail. Here, as you may have already seen, is the UA expert with a performance view. And what you can see here is first I have connected the server, then I browse down to the items I want to use for my test. Here I have a folder with 1,000 variables, which I drag and drop into the list of nodes to be used for the test. As you can see here, it's a nodes I have in my testing list is 1000, and they each have UIN32 data type, and so that's the base for my test. And then I check here the read and the read registered to show the difference in the reading mechanism. And now this client is going to read 100 times in a loop. So this is polling at full speed, 100 times in the loop, and using 100, a 500, 1000, and a 5000 nodes per each read. And with that, you can see here the curve coming out as a result, saying that you can read the registered nodes, which is 5000 registered nodes, with UIN32 values in a loop 100 times at an average of 6.5 milliseconds each read. And if you do it without registering the nodes, then it will take as an average 9.4 milliseconds, as you can see here. So you can already measure that registering the nodes before reading them in a fast loop really makes a difference. So this is the test where we can see that reading in a loop is extremely fast. Now I want to compare this to the subscription. So again, the same test. I have my 1000 tags in here in my list to be used, and I check here the subscribe test that I want to run, and the sampling interval is 0. So I'm telling the server I want to have the fastest sampling, and the publish interval is 50 milliseconds, which is, by the way, the fastest this server can do, because it's returning the revised publish interval with 50. And now again I do the cycle of 100, which means I wait for 100 data changes per each item to occur, and then I'm happy. And I do my measurement. And what you can see here, independent of the number of items I have in my publish, 100, 500, 1000, even 5000, it all the time takes an average of around 62 milliseconds. Even when I subscribe to 5000 nodes, it's still 52 milliseconds. And what you can see from here is that the publish rate needs to be interpreted as not faster than. So the data will not be faster than 50 milliseconds. And it's not. It's 62. But you need to consider which amount of data I have received in this amount of time, of course. I receive 100 value changes for each of the 5000 nodes within an average distance of those changes of 65 milliseconds. And I requested 50. So here you can see the difference. And it's not going to be faster than that, because that's a revised publish interval of the server. The only thing I can do now is to increase the number of nodes to find the dripping point where the server is not able to deliver this amount of data within the 50 milliseconds anymore. But that's a different test. So this is about polling data with a read in a loop, and to use the publish and the subscription mechanism that we have in the data change client-server communication. So as an overview summary here, the first thing to mention is OPC UA is fast. And it has the ability to read ad hoc, where you need to consider the max age because you may put load on the server. And you can read in a loop, which we call polling, and then you need to register when reading in the loop to get the best out of the performance. And of course, and even better, you use the notification mechanism for data and for events, because that's preserving the server from being overloaded, because he can consider the scan rate and the publish rate himself. So that's about what I want to tell you. Thank you very much for listening.